Yeah. Okay. Welcome to the lecture of the gradient descent. We'll be knowing what the gradient descent is actually and why do we use it. Okay. So we have talked earlier about the linear regression in which we have equation, we have a function which was a hypothesis function. So what we used to do that we had some coefficients which was like parameters which was theta 0 and theta 1 and with the product of x1 which was the feature okay. So let it be x only because we don't have the multiple features, so we're not gonna use the x1 x2. So let's suppose this is the data and this is your y. This is your dependent variable, this is your dependent, and this is your independent. Yeah, we know all these things. This is the dependent, this dependent, and this is independent. Yeah. So we had a function which was named hypothesis function. So with the hypothesis function we got a line. What we got a line which tells us the prediction. Okay, so we got a line like this is a line due to this function, and we have some data points like this. Okay, we had some data points like this, so this is the data. Now our line is not perfect aligned to the points, the point where it is. Okay, this is the point, line is away from it. Okay, it is away from like this. Let me take it here. So we have that much of distance far. Okay, so this line is far from that much of distance, that the this is the predicted value, and this is the real value. This is the real value, this is the predicted value. So we have some errors. Okay, we have some errors and we have to resolve this, because if we don't resolve the error then we're not gonna get a very good model. Okay, yeah, cool, right. So this is the function from which we got this line. Now we have to make another function which takes care about the error. Okay, that takes care about the error. So we made a function g of x. Okay, so let's name it g of theta. Sorry, g of theta, in which for which theta the predicted value is far from the data. Okay, so we're gonna get this like this. So we have like going for every iteration. Okay, for the n numbers of data. So we have some. So what will we do, that we'll use the function h of x, h of theta, sorry, h of theta of ith term. Okay, for ith term minus y I, and this will be from I to n. Okay, and we'll square it. Okay, while we square it, 'cause we want only positive number. What do we want? We want only positive numbers. Okay, we want only positive number. This will give us the positive value, not the negative value. So, and we'll add 1 by 2. Okay, what will we add? We will add 1 by 2, and we'll talk about later why do we add 1 by 2 in it. So okay, so this is the function which takes care about, just g of theta takes care about the error. Okay, that how far our predicted value is from the real value, the ground truth. Okay, so this is the function which cares about the errors. So let me write it in a new way so you'll get it. This is x of n till n numbers. Okay, till n, h of theta for ith number minus y and x h2. Okay, yeah, this is the function. We add 1 by 2 also to maintain it. Okay, and we'll talk just now why do we add it. Okay, so this is the term, remember this is the term. Okay, now we have to talk about this, that for each value now we have some theta. Okay, so we need to find the theta 0 and theta 1. Okay, what do we need to find? It's theta 0 and theta 1, but we don't know that how we find it. We can't just give a number and it will be like, yeah, this is the right number. No, we have to get idea how do we find it. So we know that let's suppose our y is 19. Okay, and our the predicted value, that is y hat, we get 14. Is it more away from the 19? Yes, is it? Okay, this is y1, this is y2, we get 18. It is like, yeah, it is 1. Okay, it is minus 1. Now the third value, the third predicted value, for what? The value of thetas. Okay, the value we got for the theta, we put in the theta the value we put in the theta, and the value we got, these are the value from which we put some value in the theta, and corresponding to the theta we got this value. Okay, for so let's suppose we put some values in the first value. Let's suppose we put some value and we got x, y hat 1, y hat 2, y hat 3. Okay, these are the different number for each theta. Okay, for each theta we have different number in the each time. This is the first time, this is the second time, and this is the third time. We all the time we had different values of theta. Okay, we had different values of theta. Now in the third time we have some new value for the theta. We got 18.7. What we got? 18.7, which is the best among all these bit. From this is the best. Okay, this is the best. 18.7, which is approx to 19, which is a great thing, which is a great thing. Okay, now we have to find out the theta, that for which value of theta we got 18.7, for which value of theta we got 18.7, because we had the function hypothesis function. We had this theta 1 into x. Okay, so we put some value on the theta. Okay, we put some value. Okay, this is now the this is x. Okay, this was x, sorry, this was the x. Sorry, I messed up. This was the x. Okay, this was the x for which we put, and we got some value. Okay, now we don't know that for which value we got, for which value of theta we got 18.7. So now this is the function, we got 18.7. Now we will know how will we get these thetas. Okay, so we made a function which was this. Okay, which takes care about the error rates. Okay, so if you see the error rate from 19 to 14, it is minus 5. Okay, it is minus 5 from the 19. This is minus 1, which is a great thing. But this number, this is our like the baby, this is the little thing which we want, which is 18.7. The error rate, the error is 0.3, which is a great thing. Okay, this which is a great thing. Now what we do? Okay, so we have a function like this. Okay, we have a function like this. Now what will you do that we, how will you find, because we have all the values of theta we stored inside the g of theta. Okay, now what will you do? As you know, let's put this function. Okay, how will you put this function on the graph? It is x of square. How will you put this function? Okay, like this, like parabola. This is a simple, like we can say a quadratic equation. This is a quadratic equation, and this is the parabola. Now let's say what is the minimum value in it. Okay, according to this parabola, what is the minimum value to it? This, as you see, this is the minimum value, right? Is this the minimum value? Yeah, this is the minimum value what we want. Okay, so what we did actually, because we made a square, so the function, the graph which will be like this. Okay, which will in the form of a parabola. Now let's suppose, not let's suppose, this is the error. Okay, this is the error, and this is the theta. Okay, this is the theta. For what value of theta we got the lowest error? Are you getting it? Okay, for what value of theta we are getting the least error, the global minimum. Okay, this is called, what we call in the term of machine learning, global minimum. What we call it, global minimum, which is the like least number, which is the closest to the closest or the nearest to the real value. Okay, so this is the nearest value, so we need to find it. Now we have the number, but how do we find it, for that for which value, or which value or the number of theta we got these little these this place. Okay, we got this. So what we do is we use calculus. What do we use it? We use a calculus. Okay, in the calculus, and we update it. Okay, let's suppose what we do in the calculus, what we do is d of x or d of y. For what value of y, for what value, how much x changes when y changes. Okay, how much x changes when y changes. Okay, how much x changes when y changes. So this is what we're going to apply. So we clearly see, we can see that if theta be 1, then we have a different number. If theta is 0, we have some different number. If theta is 3, we have some different number. So this is what we have to apply. What we have to apply is calculus. Okay, so you're going to place derivative of g of theta by derivative of theta. Okay, derivative of theta, derivative of g of theta, but j is like the number, like which number. Okay, so j is the like simple the iteration number, or what value of what is the position of j. Okay, this is thing for which how much g changes. Okay, how much g changes when g of theta changes, how much g of theta changes when theta changes. Okay, so this is what we are gonna use. So this is the thing which you have to use. Now before that we have to update it also. So how will you do it? That we'll make some prediction. Okay, we'll make some prediction in this thing. What we'll do that we'll make prediction, and we will use this thing. Okay, so let's suppose we are predicting and we'll see that if we get a number which is not closest to this. Okay, so we'll compare this and we'll use this, and we what we'll do that we will put some number, random number, and we'll get for which number the lowest number we're getting, the lowest output we're getting. This is the lowest, this is the nearest or the closest to the number, so this is the lowest. And if we get more from it, like let's suppose this is the 5, this is the 3, this is the 2. Okay, like this is all the thing. Now if we get 6, we'll come back to the position. If we get 3, we'll go back to the this position to the 5. So we have to find the 5. Okay, we have to find the 5, and we have to update the theta also. Okay, we have to update the theta also because we're not going to the number due to the last iteration. Okay, the last number we gave, this is not going to be the number we will use. What will it be if we use that this theta? Okay, this is the theta. Now the updation of theta is like not beta, it's theta. Okay, theta minus alpha. Okay, alpha is the learning rate, we'll be talking in the later lectures. So this is the alpha, and g of theta by derivative of theta j. Okay, this we got it. This is theta, and this is theta minus alpha rate, so this is 0, theta 0, and theta 1 by alpha j of theta by theta j of j. Okay, so j is like 0 or 1. Okay, j is for j, for j for j 0 7 0 to 1. Okay, this is the thing. Now but the most important thing we haven't talked about, that we have to put a random value to it by our own self. Okay, we have to put some random value in it by our own self. So that will use that for theta 0, we'll put 0, because 0 won't affect this equation, but if we put the 0 to in it, then it's gonna like affect a lot. So what will you use that 0 to it, and like ignore the sound in the background, and 1 to it. Okay, one and neither 1 nor 0 gonna affect this whole function. Okay, so we put theta 0 equal to 0 and theta 1 equal to 1. Okay, now this is the rule of updation, this is the rule of, this is updation. Okay, this is the updation of theta, this is the updation of theta, because we have to find the theta for the which value of theta we got 18.7, or the like nearest value to it. Okay, now we have to expand it, we have to expand it, because the derivative we're not gonna leave it in the manner that the computer gonna do it by itself. Yeah, it will be like due to some frameworks like numpy and all those calculations, but we have to expand it and we have to understand what is being done behind. So we'll expand it, and how will we expand it? J of theta by derivative of theta j. Okay, how will expand it? We know that derivative of this, how much j of theta changes when theta changes. Okay, so what we know that j of theta is this, j of theta is this. Okay, j of theta is this, so 1 by 2, and this is theta of x. Okay, we have to, sorry, I made some mistake, it will be x. Okay, it will be x, it will be x, yeah, it will be x. Now h of x, ith position, and y of ith, and this is gonna be used. Okay, yeah. Now in the calculus, if you haven't read calculus, then like read it from somewhere. But now what we do is that we use the derivative of this, like from this. So we have a derivative of this, it's this. Okay, g of theta j, yeah, we know it, into 1 by 2 it, and we'll write it same here. Okay, we'll copy paste all this thing, this minus y of this. Okay, right. Now, according to the calculus and the chain rule, what we get here is directly what we get here is, so this is gonna be, we'll come to here cause like it is like this. Okay, it is like this. Okay, v minus 1. Okay, so in the minus 1 what we do that we will expand it. So how will you expand it? That we will use 2 will come here, 1 to 2 into 2. Okay, into h of x of I minus y of I. This is 2 of 2 cancels each other. Okay, now what we do is we will into, according to the chain rule. Okay, d of, and d derivative, sorry, derivative of this and derivative of h of x of I minus y I. Okay, this is the thing what. Now this is the term we got and this the term we got. Okay, so this term what we got is h of x for I minus y of I into derivative of h of x of y minus yi by theta j. Okay, now we have a what we have a clue here, or we have a, like something twist here. Okay, now if you know, then this theta depends on this. Okay, for which theta we get this, so there is no any concept of y. Okay, how we can write this, we can write this by like, this is here, we can, but we can expand it in a way that, how will you write this function? Okay, we will write this function now, theta 0 plus theta 1 into x. Will we write it? Yeah, of course we will write it. And minus y. Now for which value of theta, okay, for which value of theta this is going to affect? Okay, the only term will matter to us is this term. Are you getting it? Is this term, not this, only this. How much this term changes when theta j changes? Okay, are you getting it? How much this term changes, because if we have 0, okay, so this term won't gonna affect that much, but this term, okay, this term, because we have x. Okay, we have x to it, and this is the more weighted value, this is the more weighted value, for which term we gonna get this thing. Okay, so what we get actually at the end, h of x of I minus y, and which term will matter is theta j with theta, it's xj. Okay, what matters is x of j. So the last term we got is h of x minus y I into x of j. Okay, so this is the term we got. So yeah, this is how the gradient descent work. Gradient descent is a simple knot algorithm to find the the theta for which we got the nearest value to the ground truth. Okay, yeah, we'll be meeting in the next lecture.